Hello students, we are solving the system of linear equations with the Gauss-Seidel method, that is also said as the extension of Seidel. This is a numerical method to solve up the system of three linear equations. Now, to write up the general formula, before solving the particular example, we need to know about the general formula. Consider the system of linear equations a11x plus a12y plus a13z. These are just the coefficients of the variable a11, a12 and a13. And consider the second linear equation a21x plus a22y plus a23z is equals to b2, and similarly the third linear equation. To write up the formula for the Gauss-Seidel method, from the first equation you have to solve it for the x. To solve it for the x, you need to move all other terms on the right side, like b1 minus a12y minus a13z. You have to solve it for x. Now a1 when is multiplied with the x, so it's going to divide on the right side this way. Now solve the second equation for the y. So if we solve it for the y, keep the y on the left side, move all other terms on the right side, and it will be b2 minus a21x minus a23z. And there is some coefficient with the y, that is a22, so it's going to divide on the other side this way. Now take the third equation and solve it for the value of z, this one. So keep the z on the left side and move all the terms on the right side to the b3. So z is b3 minus a31x minus a32y. And you know that there is some coefficient with the z, so it's going to divide on the other side this way. Now I just solved it for x, y and z. To apply it as the extension of Seidel, or you can say the Gauss-Seidel method, you have to take some iterations, some approximations. So to run those iterations or the approximation, you need the value like first approximation, second approximation, third approximation, and up to so on. For that purpose, you must know that x raised to power n is going to be equal y raised to power n minus 1 and z raised to power n minus 1. N minus 1 and n is the number of iteration. Then yn is xn, because you found the value of xn, you will use it here. And zn minus 1. For zn, you found the value of x already here, so take it as xn. You found the value of yn already here, to take it as yn. So this is the general approximated formula for the Gauss-Seidel method. Now we are going to use this formula in our example. So you have to find the solution up to 1 decimal place. You can find it up to 2 decimal place, 3 decimal place, and up to so on. Right now, to minimize basically the time, I'm just finding it up to 1 decimal place. So once it's repeated up to 1 decimal place, I will stop my question and this will be my solution. So let's start it. First of all, you have to take the initial approximation. Your initial approximation is x to the 0, y to the 0, and z to the 0. This is the 0th iteration. So take it as 0 always. Always in the Gauss-Seidel method, take the initial approximation as 0. Now we are going to find the first approximation. For the first approximation, n is 1. This one that you took here. N is going to be 1. So take it as x to the power 0 equal 1 over a11 b1 minus a12y and n is right now 1, so it's y to the 0. So it's going to be x to the 0 equal x to the 1, because it's the first approximation, n is taken as the 1, equal 1 over a11 b1 minus a12 y to the 0 minus a13 z to the 0 this way. The same thing, you just plug in n as 1. So it will be 1 over, take the value of a11. This is your a11, a12, a13, b1, a22, 21, a22, a23, b2, a31, a32, a33, and b3. So a11 right now is your 20 and b1 is 28, minus a12 is 2 and y of 0 is this 0, minus a13 is 6 and z of 0 is 0. Now you need to solve it. So if we will solve it, it's going to be 1.4. Fix your calculator up to 4 decimal places. Okay, then I found the x1. Now you need to find the y1. Again you have to take the n as equals to 1. So y1 is going to be 1 over a22 b2 minus a21 x to the 1 minus a23 z to the 0. So 1 over a22 is 1 over 20, negative 23, negative a21 is 1, and x1 is this value that you already found, 1.4. And a23 is 9 and z0 is 0. Now you need to solve it. You will get negative 1.22. Now I need to find the z1, and z1 is going to be, you have to use n as 1 here, so it's going to be 1 over a33 b3 minus a31 x to the 1 minus a32 y to the 1. After writing it, you have to use the values here, plug in. You will get here 1 over a33 is your negative 20, b3 is negative 57, negative a31 is 2, x1 is this previous value 1.4, minus a32 is minus 7, and y1 is minus 1.22. Now solve it. After solving it, I will get here 3.417. Now you need to find the second approximation, and you have to solve it until you get up to 1 decimal place, the same repetition of the number. So the second approximation is going to be the same way. For the second approximation, you have to take the n here as equals to 2. So n is equals to 2 for the second approximation, and that will be x2 is 1 over a11 b1 minus a12 y1 minus a13 z1. Now take the values from the previous. You found this value, you found this one, and these all are in your system of linear equation. So after plugging in here the values, that is 1 over 20, 28 minus 2 times minus 1.22, 6 times 3.417, you will get here 0.4969. Now let's find here the second approximation y2, 1 over 20, negative 23 minus 1 times 0.4969 minus 9 times 3.417, and that's minus 2.7125. Similarly, you will find the z2, that is 3.8491. Now after finding this, you have to look at the answers. The x1 was 1.4, it's 0.4, it's totally different. And y1 is negative 1.2 and it's negative 2.7. 3.4, 3.8, nothing is repeated. So you need to find your third approximation now. For the third approximation, you have to take the n is equals to 3 in your this equation. N is equals to 3, plug in the values, and you will get here x3 as 0.5, y3 as minus 2.9, and z3 is 3.9. Again, nothing is repeated, you see. You just got it this way, just this repetition, and nothing else. You have to repeat it until one decimal place. So let's find the fourth approximation now. So the fourth approximation is going to be, for the fourth approximation, n is equals to 4. So we will get here x4 is 0.5150, y4 is minus 2.9395, and z4 is 3.9303. Now look at this, both answers. See, it's repeated up to one decimal place. Repeated up to one decimal place. Repeated up to one decimal place. So I wanted the answer up to one decimal place. So I'm going to stop here, and this is my solution. If someone asks you to find up to 2 decimal place, so you have to repeat your approximations until you just get repeated the answer up to 2 decimal places. I hope you understand this method.